Hello viewers, welcome to my channel. Now in this video we want to apply the remainder theorem to look at number 1 question and the number 2 question. So in a previous video we talked about the remainder theorem and we had to go ahead and prove it. Alright, I'm using some equations involving the polynomial, its divisors, its quotients and its remainders. Okay, anyway, let's just apply that here and solve this. But before that, I would like to just write down the equation for you guys to see and just say some things before we continue. Okay, great. So here we have that when we are given a certain polynomial like this one, which is of degree 8, okay, we can put it down as p, just call it p of x, right? Let's call it p of x, that this is the same thing as, this is a divisor of it, so we can put it down as d of x times, there is what we call quotient. After dividing, you get a quotient and you get a remainder. Okay, so that is just it. When you get a quotient, you get a remainder. You can multiply the quotient with the divisor. You add the remainder. You get back the original polynomial you were given. Now, but in the factorization theory, in the remainder theorem, when we have the divisor to be x minus alpha, for example, it means that x is equal to alpha is a certain number that will give us the remainder when we substitute. So let's just look at this. So we have to find the remainder when this polynomial here is divided by x minus 1. Well, first thing is for us to notice that when we are given this particular stuff here, this factor, okay, maybe this is not a factor of this polynomial, maybe it's not. But when we are given this divisor here, you have to, first of all, the idea is to equate it to 0. So if you equate this to 0, x minus 1, you solve for x here, alright? So what is the value of x that satisfies this equation? You know, x is equal to 1. You will add 1 to both sides. Okay, so if you substitute this 1 into this polynomial here, you are going to get the remainder. Substitute this one in place of x in this polynomial, the result is going to be the remainder. So the remainder is gotten from the root of this divisor, alright? When you plug that in. Okay, great. So let's just look at it. So since this is divided by x minus 1, it means that x is equal to 1, okay, is the value. So we are going to write that polynomial in terms of 1. So in place of x, we are going to put 1. That will mean 3 times. So in place of x, we just put 1 raised to power 8 plus 2. In place of x, we just put 1. So we put 1 over here. We raise it to power 7. We go ahead and do the same thing. This is 1 to power 6. And then 1 to power 4 minus 2 times 1 to power 3. Then minus 5 over here. So hoping from the remainder theorem that when you substitute this 1 here, that is this part here, alright, into the polynomial, you are going to get the remainder. So to find the remainder is to substitute 1 here. So since this is just minus, we just put 1. If this place is plus, like in this case, we are going to use negative 3. We will get to that. So here we can see 1 raised to power 8. In fact, everything will be simplified. So we can simplify this down to 3 plus 2 plus 1 minus 1 minus 2 minus 5. Knowing that 1 raised to any power, okay, the result is going to be 1, provided that power is a real number. Okay, so we have 1 times 3 and so on. So if you add up everything here, noting that this and this will be 0, this will be negative 7, okay, and this is 5. The result here is negative 2. So after everything, we get negative 2, and negative 2 is the remainder. So we can say this is equal to the remainder, and that ends it. So that is the result. Okay, well, so that is it for the first question. So all you need to do is to get this one, equate it to 0, equate this divisor to 0, get the value of x, substitute the value of x into the main polynomial, okay? So when you do that, you simplify things a little bit and you get back the remainder as an output. Okay, great. Okay, thanks for watching. Come back for the second question. Just check, you will see it around somewhere. All right, let's move on to the second question.